In this lecture, we will discuss data and process modeling. System analysts use many graphical techniques to describe an information system. A data flow diagram uses various symbols to show how the system transforms input data into useful information. A data flow diagram shows how data moves through an information system but does not show the program logic or processing steps. A set of data flow diagrams provide a logical model that shows what the system does, not how it does it. In a data flow diagram, there is 4 basic symbols: the process symbol, data flow, data store, and the external entity. For the process, you must have at least one process input and at least one output. It contains business logic that transforms the data. You have a process name that identifies its function. A process number does not signify precedence. Example, you can have a process name that says print bill or add customer. For data flow, it represents one or more data items. The symbol for data flow is a line with a single or double-headed arrow. In the example, it shows you a process symbol as well as a data flow. The first example shows a create invoice. Inside create invoice, it has coming into the process, services performed, and going out of the process, an invoice. Again, having an input and an output. The next one shows submitted work going into a grade student process, having the output of the graded work and the student grade. The next one shows and calculate gross pay process with an input of hours worked and pay rate and an output of gross pay. The last example shows 2 processes, one called verify order and the second called assemble order. Verify order has an input of order, an output of accepted order, which is also an input to assemble order, which has an output of inventory change. The key here is, again, each process must have something that goes into the process as well as something that comes out of the process. The data flow symbol is spontaneous generation, black holes or group holes. Here shows you some incorrect examples of data flows. Here you have apply insurance process, but you have 2 outputs. You have a policy number and a payment number. It's incorrect because remember, you always have to have one input and one output. It has 2 outputs. For calculate pay rate, this one has 2 inputs. You have hours worked and pay rate coming in, but no output. And the last one would be you have calculate grade, you have date of birth coming in, and then you have final grade coming out, which means that basically you have a mismatch of the data type. So the input couldn't work because date of birth could not be used in actually calculating a grade. So that would represent an incorrect data flow. The next symbol that we will look at is the data store. It represents data that the system stores. A data flow diagram does not show the detailed content of the data store. The specific structure and data elements are defined in the data dictionary. A data store must be connected to a process with a data flow. Here it shows you a data flow diagram where a data store is connected to a payment, post-payment process. Then you have a data store called daily payments, and then you have an output coming out of that called daily payments going into a process called prepared deposits. The next data store you have is an accounts receivable data store that has information coming in from the create invoice process, and it has an output and an input coming from the payment, the post-payment process. The invoice detail comes out of the data store and the payment detail goes back into the data store. So it has both data coming out and going back into the data store. The last correct diagram shows you have a admit patient process. The output going into the data store for patients is the admission forms, and then coming out of the patient is the diagnosed patient, and they have treat patient that goes back into the data store. Some incorrect example is that a data store cannot go into another data store as showed below in courses and students. Both of those are data stores. Remember, a data store must be connected to a process. Here you also have a post-payment process going into daily payment. You can't have that because you don't have an intervening process, and that's the case with both book, flight, and the passenger data store. The data flow diagrams show how the system interfaces with the outside world. A data flow diagram shows only external entities that provide data to the system or receive output from the system. A data flow entity are also called terminators because they are data origins or final destination. Each entity must be connected to a process by a data store. Here we have a data store of entity that is customer. The customer makes a payment, and then you have an apply payment process. You have a bank receiving information from the prepare deposit process. The last example, you have a customer who places an order, and it has verified order, and after the order is verified, the customer would then receive an invoice. The last one is that you have a verified time card. You have an employee who will input their time card. It goes to a verification of time card, and then a create paycheck, which again goes out to the customers. Some incorrect examples is that you can't have two entities connected, and an external entity must be connected by a data store to a flow and not directly to the data store to another entity. So that's why the last two are incorrect. When you're creating a data flow diagrams, you must first draw a diagram 0 data flow. If the same data flow in both directions, you can use a double-headed arrow. Diagram 0 is an exploded view of process 0. You have a parent diagram, child diagram, and then a functional primitive. So this shows you an internal data flow diagram. The next step you would do is draw a lower level diagram. This breaks out a process in more detail so that you can get a better idea of how the data flow works. The last portion of the lecture, we'll talk about a data dictionary. A data dictionary or a data repository is a central storehouse of information about the system's data. An analyst uses a data dictionary to collect, document, and organize specific facts about the system. Also defines and describes all the data elements and meaningful combinations of data elements. A data element, also called a data item or a field, is the smallest piece of data that has meaning. Data elements are combined into records, also called data structures. A record is a meaningful combination of related data elements that is included in a data flow or retained in a data store. Here just shows you an example of documenting the data store. You have the data store name or label, you have a description, you have alternate name, you have attributes, and then you have the volumes and then the frequency. Next we look at the logical versus physical models. While structured analysis tools are used to develop a logical model for the new system, such tools also can be used to develop physical models of the information system. A physical model shows how the system requirements are implemented. You have sequence models. Many system analysts create a physical model of the current system and then develop a logical model of the current system before tackling a logical model of the new system. Performing that extra step allows them to understand the current system better. There's 4 approaches. You have to develop a physical model of the current system, then a logical model of the current system, a logical model of the new system, and then a physical model of the new system. The only disadvantages of the 4 model approach is the added time and cost that it takes to create the models.